The second lecture on multiplying decimals is going to look at the shortcut. So we have to come up with maybe what we call an algorithm or shortcut in multiplying decimals, because oftentimes it seems fairly lengthy to write all these decimals into fractions, multiply, and then convert back to a decimal. If we look at the first problem, 1/10 times 1/10, because of multiplication, my denominator actually got larger. So if we take a look, there is one digit to the right, and there's a second digit to the right in the problem itself. So if you look there are two digits to the right of the decimal. My answer has two digits to the right of the decimal. Let's see if that holds for this problem, the second problem. There are two digits to the right on the first part, one digit, so there are three digits to the right. The answer has three digits to the right. Checking out the next problem. There are two digits to the right, and my answer has two digits to the right. So let's go ahead and try the shortcut method and see if we get the same result as we did the partial products. 1 4/10 times 3/10. I'm going to ignore place value for a moment here, and I'm going to multiply 3 times 4, even though it's really 3/10 times 4/10. 3 times 4 is 12. I have a position for the 2. The 1's get regrouped. 3 times 1 is 3, plus 1 more is 4. Notice my values match, and the position of my decimal, if my pattern or rule holds here, 1, 2 values to the right of the decimal, 2 values to the right of the decimal. Let's try the other problems here. 32 100ths times 4/10. 32 100ths times 4/10. Again, ignoring place value. 4 times 2 is 8. Distributing the 4 to the 3, 4 times 3 is 12. Following my pattern or rule for the algorithm, there are 3 digits to the right in the problem itself. So my decimal must land right in that position. And again, notice the answers match. 5 and 3/10 times 2 and 5/10. 5 and 3/10 times 2 and 5/10. Ignoring place value again. 5 times 3 is 15. Regroup the 1 from the 15. 5 times 5 is 25, and 1 more is 26. To use our standard algorithm for multiplication, if you remember, we need that placeholder there. 2 times 3 is 6. 2 times 5 is 10. Adding my columns, regrouping the 1. Decimal placement. There are 2 digits to the right of the decimal, so my answer, there must be 2 digits to the right of the decimal. Last problem. 3 and 11 100ths times 1 and 5/10. Ignoring place value and distributing the 5. 5 to the first one, 5 to the second one, and 5 to the third. Number 3 is 15. Doing my placeholder, 1 times 1 is 1, 1 times 1 is 1, 1 times 3 is 3. Combining my columns, checking my decimal point placement. There are 3 digits to the right, so my answer must have 3 digits to the right, and you can see that the answers hold.